My name is Claire Dyer, and I teach Algebra 1, 8th grade math, and gifted at West Feliciana Middle School. As an educator, I am passionate about helping students develop grit and mental toughness so that they can bring that not only to the math class, but to other academic areas. This lesson that I'm teaching is in the middle part of teaching factoring with polynomials, and in particular, we're going to be factoring trinomials. So before this lesson, we have found the greatest common factor, we have factored difference of squares, and now we're tackling trinomials where a equals 1. The curriculum that I use is Envision Algebra by Pearson, and I make use of their Savas Learning, which is what used to be Math Excel, as well as teacher-created packets, guided notes, and practice problems. This class is a hybrid class, which means I have 4 kids who are joining virtually. They've been doing that since the beginning of the year, so it's a well-oiled routine that they have, and everyone is comfortable with that. And so the only thing that really affects me in class is that I stay tied to my slate that I use more than I normally would, so that I can make sure everything I do is on the board for the virtual students to see, as well as the online students. The overall goal here is to get kids to be proficient in factoring and solving quadratics, because in the second half of this semester and the rest of the year, we'll be doing quadratic word problems and application problems. And so they have to be well versed in this beginning part, this foundation, so that they can be successful later on. So we'll see how it works out. Okay, so before we go on today, because I think it's important to remember where we have come from, right? So we are going to be factoring trinomials. But if you look on what we see now, Mel, can y'all see this? Did I lose them? Okay, good. Okay, we did this a few days ago when we were multiplying. And so I want you to pay particular attention to what we started with. Let's look at number 5. We had 2 binomials that we multiplied together, and we ended up with this thing. What is this called? A trinomial, okay? So it's really important then to make sure that we understand that this trinomial came from multiplying those 2 binomials together. So what we're going to be looking at today then is how to start with a trinomial and factor it, break it back apart into those 2 binomial factors. So the first thing I want us to make sure that we remember is standard form. And this is what standard form looks like. ax squared plus bx plus c. Please notice a is the coefficient of the quadratic. B is the coefficient of the linear variable, which has an exponent of 1. And c is the constant. First of all, these trinomials, if you'll notice, every single one of them, if you just glance at the page, the leading term has a coefficient of 1. And so these trinomials, this method we're using is specific to a equaling 1. And all of these are like that. And so this is one method, and then once we get proficient at it, we are going to, of course, move on to another type of trinomial. So let's look at these little notes here. I need 2 integers when I'm factoring. And so, of course, you know from FOIL, our first term has to be x here and x there, so that when I multiply, I end up with x squared. But now I've got to figure out the rest. So this is our method. Draw this here, and this is simply an organizational tool. It's not like set in stone in terms of part of your answer. It's just a way for you to organize your information. And so it says I need 2 integers that multiply to c. What is c in this trinomial? 12. So I'm looking for 2 numbers that multiply to 12. And then I need 2 numbers that will add up to b. What is b in this trinomial? 7. Sir, you got it?
Oh, yes, ma'am.
Tell me.
4 and 3.
4 and 3. Can y'all figure out how I got those numbers? Because 4 times 3 is 12, and 4 plus 3 is 7. Okay, so now I've got 4 and 3 here. How do I know if it's going to be adding or subtracting?
They're both positive.
They're both positive. I need a positive 12, which means my signs have to be the same when I multiply. But I need a positive 7, which means both those numbers have to be positive.
So to factor a trinomial, can you use the other steps that we've been using?
A difference of squares. So how many terms were we talking about there?
2.
So that method is not going to work for a trinomial because it's 2 terms. This is 3 terms instead of 2. okay? So you're going to notice as we move on, remember we're going to be looking for a greatest common factor ultimately first. Right now we don't have any, but later on the page we will, huh?
But if there is, that would be the first thing we do.
Yes, yes. All right, so yes ma'am, Rachel.
But how would you get the 7?
Oh, that's a good question. So if we're going to multiply it back together, let's do FOIL. So x times x is,
X squared.
okay.
I see.
You got it? Yeah, plus, okay. So then we do the outside terms,
3x
plus 3x,
plus 4x
plus 4x,
plus 12.
and then plus 12.
And then you add the middle squared plus 12.
Then we combine our like terms. Okay, so why don't we go all the way to 6, and then we'll check that in just a sec. If it's prime, what goes into it? All right, let's see how we're doing. Anybody have number 3? All right, what do you have, Marley?
H plus 6. And then H plus 3.
All right.
The number 3, I
Oh.
have H plus 9 times H plus 2.
Okay, but if you put a 9 here and a 2 here, it does multiply to 18, but then when you add them together, you don't get that middle term. So remember now we had to be thinking about 2 constraints here. The last term has to be a multiple of those 2 things, but then the middle term has to be the sum. And last one, okay, Amber?
I said y plus 1 and y plus 1.
Okay, so let's stop here for just a sec. What then do you notice about those 2 binomial factors? They are the same, is what Rachel said, and that is true. So, is there another way to express this then, Amber?
In parentheses, y plus 1 to the exponent, to the power of 2.
Okay, squared. Okay, this is called a perfect square trinomial because the factors, the binomial factors, are the same.
So for number 5, I got k plus 2 and k plus 3. Did that work?
Well,
That's right.
okay, I can see why you did that because you're thinking of things that make 5, right? But we have to multiply to get to this number. And 2 times 3 is not going to give you the 5. Okay, so you multiply to get C, and then you have to add to get here. Okay, so what I would like you to do then is do 9 through 12, and then we'll check it.
But why are we only showing like 2 here?
It's not s to the third.
Like there's 3.
I know there's 3 s's, but one of them is s squared, and one of them is s to the first. And since we're adding, remember, the only time you add those exponents is when you're multiplying powers of the same base. Okay, I'm going to put Terrelyn on the spot. Terrelyn, you have number 11? Will you tell me, please? Okay. What do y'all think about that?
I agree.
You agree? All right. 2 thumbs way up, Terrelyn. Okay, so let's scroll down then to the bottom of this page. So you remember how I always tell you that we just add layer upon layer upon layer? So look at this one. Look for GCF first. So as you're looking at 31, do you see a GCF? 4. So we're going to pull out 4. And that's going to give us 4 times what?
N to the second.
N squared.
Plus 3n plus 2.
Plus 3n plus 2. So then how are we going to factor n squared plus 3n plus 2? Amber?
Well, we can draw the x, and I got n plus 2 and plus 1.
Okay, so once we then focus our thinking on what we're looking for, something that multiplies to 2 and adds to 3, she said n plus, what'd you say?
N plus 2 and n plus 1.
N plus 2 and n plus 1. All right, so now let's look at number 34. How is this one different?
Because they all have variables.
Ah, they all have variables. That is true, Addie. And you said it has an a to the what? That's a to the third power. So do you see then a common Factor.
3.
3A.
3A.
Okay? So since we have an A in every term, an A is common to all of them. So then what's the trinomial after we factor that out?
A squared plus 10A plus 22.
21. Yeah, 21.
All right, AJ, what you got?
3A, in parentheses, A plus 7, and then in parentheses, A plus 3.
I agree. We're good.
We are good. So that brings us now. So now we get a time to practice. I've reconfigured the channels in Teams to, did I skip y'all, of course? To reflect your new grouping, like your seats. All right, so Riley and Nick and Carolyn and Mel. So this is in Teams under handouts. And so y'all still have your virtual channel, but you also then are stuck into channels with people in the room as well. Okay? So y'all can work together.
Wouldn't it be prime because to equal negative 99, that would, nothing that would multiply into negative 99 would equal negative.
What do you, okay, tell me.
Okay, so it has to, you have to multiply to get to this, and then they add up to that.
So let's go through our factors of 99.
9.
9 times what?
10.
9
No,
times
9 times 11.
9 times 11.
Okay, I was
9, 10, 11. 8 and 11? Oh, 8 and 3. I was like, hey, that doesn't work. I was looking at 11.
How you doing, Nick? Good? I'll turn my camera so you know I'm talking. Okay. Riley, what about you?
Good.
Okay. Let me know if you have questions. Carolyn, we good?
Yes, ma'am.
All right. Mel, yes?
Yes, ma'am.
Okay. All right. Sweet.
4 and 9.
4 and 9?
Yeah. Or like 3 and
has to
3,
add up to
3 and
9,
12. 3 and 12.
Negative.
Negative 3 and 12.
It has to be. Oh.
12 times 3.
Yeah.
All right. So everybody stop what you're doing for just a minute. And if you don't mind, if you would stack those little plastic folders on your desk so I can pick them up in a second. Okay. So these task cards are also in Teams. If you prefer, I'll also put them in on course. They're due Friday. Hey guys, okay, look, now if y'all have questions, make sure you send me a remind, let me know so that we can make sure we get them answered between now and Friday, okay? All right, I'm gonna end the meeting and I will see y'all later. So I feel like my objectives for this lesson were met. Tomorrow we'll really tell the story if they were able to successfully complete some of the tasks that I gave them to do. But since we set out to learn how to factor trinomials where a equals 1, I felt like the majority of the class made great strides. One student was really struggling, but he's been out a couple of days, and so he feels a little bit out of water for that, so we'll have to make up some of that time in another class. Before this lesson, we had begun working on factoring, and so some of that came into play, especially pulling out the greatest common factor, and they saw that that's not just a skill in isolation, that they have to use it all the time. And so going forward from here, we'll finish up with our task cards, our practice problems. We'll use our Savas Learning Math Excel, which has some more strenuous problems in it, where they have to do some more thinking, and we will finish up the week with a quiz. And so I'm satisfied with their progress in understanding, and I would probably focus a little bit more on their multiplication skills beforehand. I would make sure they were able to recall their multiplication facts and understand that's what they're drawing from. Sometimes their dependence on calculators comes out in a lesson like this where we're not using one, and they have to have those recall numbers. Their number sense has to be quicker. And they noticed that today, and they got stuck sometimes when it had to just be 1 times 5, and they couldn't figure that out. And so brushing up those skills is something that we work on constantly. But overall, I'm satisfied with the progress that we made today.